Hi friends, so today we are going to solve this problem number 153, which just says find minimum in rotated sorted array. As you can see in the problem description, we are given an array which is sorted in ascending order, and it is rotated at some pivot unknown element. So we don't know which element it is rotated from, and the task is we need to find the minimum element in the given array. So we will follow these steps. That's basically, first of all, we'll ask any clarifying questions, and then understand the problem. So in terms of this given problem, as we can see from this given function definition, we are given an array of integer, which is nums. So just to clarify some questions, we can ask like, how do we handle the edge cases, like what if the given array is empty or null? What should be the return? In this case, the return is an integer, so maybe we can just assuming in this case that we can return 0 as the minimum element. The other clarifying question can be, what if the numbers is null? So in that case as well, we can say, just assuming for now that we will return 0, um, and just trying to understand the problem that we are given the array which is already sorted in ascending order. Okay, so once we get the idea of the problem, the second step would be to come up with the brute force solution. So since we need to find the minimum element in the given array, the naive approach would be like just sort the array again, and then in the ascending order, and then whatever is the first element at the index 0 in the sorted array, we can say that's the minimum element in the given array, and that would be our brute force solution. And the time complexity in that case would be n log n, because we'll use array.sort in Java. So that's the n log n time complexity. But um, if we look at this problem carefully, we see that the given array is already sorted in the ascending order, and the idea behind giving this sorted array means that we can do better. So anytime when we hear like sorted array, the first idea that comes into mind is the binary search, because binary search improves the searching capability by log n time. So if we somehow we use the binary search in this given array, we can improve the time complexity to big of log n time. So how can we implement? How can we use the binary search and implement this function? Um, so let's see. I have just given. I have just used the given example as here. So this is our original array, which is already sorted, and now we have some pivot element where the array has been just shuffled, right? So in this case, it's from here. The pivot element is 0, so it has been rotated from this element 0. So 0, 1, 2, and then 4, 5, 6, 7, right? So that would be our rotated array. So if you think about it, in the binary search approach, let's try to come up with our thought process, right? So the first step is, in the binary search, we know we take 2 pointers. One is the low, which we start from the 0th index, and the high, which is the last index in the given array. And then we determine the middle element. And so in this case, let's say it will be, in this case it would be 7, because 7 is in the middle of the given array. So 3 elements on the left and 3 elements on the right. So our middle element is 7. And so in this case, we check the middle element with uh, like either the low or the high. So let's consider this is our low and this is our high variable. Um, so we check this our middle element with the in this case let's just do high. So if 7 is the middle element is greater than high, that it means our lower or the minimum element is somewhere towards the right side from the middle, right? So then in that case we update our low pointer to mid plus 1, because then there is no point of looking into this direction, right? Because we know that the high is lower than the mid element, so we only look into this right direction from here. So now in the next iteration our low becomes 0, and our so nums of low is equals to 0. So let me just write it down here. So in this case nums of low becomes 0, and then nums of high, we keep it same as 2, right? um, so our low becomes here. So let me just point it out here. So our low is here and then the high is here, right? And now we iterate through, iterate the same procedure until the low and high are same. I mean, so we will we will use the while loop for that. So we can say something like while low is less than high, and then we will just repeat the process. So we can say something uh, here we will just say update low and high based on some condition. Right? Okay, so our logic will go here, and in the end, as you can see, our uh, low is our pointer where our minimum element will reside, right? So in the end, low is the index where our minimum element is there. So in the end, we can just say return nums of low, and that will be our minimum element in the given array. So in this case, we use the binary search approach. We compare the middle element while iterating through this while loop, and then we will keep doing that comparison until the low and high, until the low is less than high index. So this approach looks like is a good approach to work with, and then by this we achieve the time complexity of big of log n. Okay, so hopefully this clears our the thought process, and then that's how we can optimize our solution. And then this is the thought process that we can share with the other with the other candidate or the interviewer, and get the agreement on this. And then once we get the agreement and find that this is the most optimal solution that we can come up with, we can start coding. So while coding, these are the points that we should keep in mind, that we handle the edge cases, the code is clean, concise, and in the end, it should be well tested as well. So keeping these things in mind, let's start. So first thing first, we handle the edge cases. So edge case, as we discussed in the beginning, that what if our nums array is null, or the length is 0. So in both cases, we just simply return 0. Um, and now we need to take 2 pointers. So use 2 pointers and binary search approach. We'll say, let's say 2 pointers. So one is integer low, which will be the 0th index, and integer high, which is the last index in the given array. So nums.length -1. And as we just discussed, we'll use the while loop. So while low is less than high, first of all we'll use find the middle element. So the middle index would be always use the low plus high minus low divided by 2, because we don't want the integer overflow. So never use low plus high divided by 2. Always use low plus high minus low divided by 2. Um, so avoid integer overflow here. So this is the best practice to follow, and keep this thing in mind. And now once we get the middle index, we can start comparing. As we discussed over here, that we compare with the element at the high index. So we say if the nums at the element at the middle index, if it is greater than the index at high position, so in that case, what do? We update our low index to the middle plus 1. That becomes our new low index. So we say our low is equals to mid plus 1, um, because there is no point of iterating through the left of mid in that case. And what if there is no this isn't true? So in that case, what we need to do is move our high index as a mid, because in that case, in the opposite direction, we need to look only this the left portion of the array, from low to mid. So our high becomes a mid. So our high index will point to the 7. So in that case, we update our high to mid, and then we iterate again in this loop, and then we'll keep comparing. And once the low and high become same, our low is the index where our minimum element resides. So after this for loop, we can safely say return nums of low, and that should give us the return the minimum element in the given array. Okay, so also make sure in with the interviewer or the other candidate in the beginning that make sure that we want to return the actual element and not the index, because sometimes in the in the interviews, the interviewer wants to return the index at which the minimum element resides. So in that case, we'll return low. But since in this particular problem, we need to find the minimum element, not the index, so we will return the nums of low, which will give us the minimum element in the given array. Um, so I guess that's it. And following our steps, we need to verify with using the test cases. So here we we can walk through this problem statement here with this given test case, that we started with 4, 5, 6, 7, 0, 1, and 2. So initially our low element was uh, the low index was 0, and then high was at the last element, and then the middle was 7. So we only iterate on the right side of the array. So our new mid becomes uh, um, like 1, and the low is 0, and the high remains 2. And then we do it again. So because the mid is the nums of mid is less than nums of high, so in that case we move high to the mid. So now our low is at the 0th index and high is at the first index. Um, and now since the mid will be the 0th index, and in the end we will return 0 as nums of low, and that's our answer. So I mean, you can try different test cases, make sure it works. So let's try this out with this solution. So if I say run code, uh, and yes, it found one as the minimum element in the given array. But let's quickly try this one as well. So if I copy this and then we can run this as another test case, say run, um, and then it says 1010. So yes, it gets accepted, and so that's how we can verify our code using some test cases. Let's make sure that it also takes care of an empty element or only one element. So if we say just one, um, and I mean in this case it's already given that um, the we the array is already sorted, so this one only one is already a sorted array, so that's a valid input. And let's try again. Um, Reference binding to null pointer of type integer. So I guess it has to have at least more than one elements. So let's not worry about that test case because seems like it has to have more than one element in the given array. So yes, so let's say can submit this and let's see how it goes. And yes, it does actually beats 100% Java Online submissions, and that's how we can verify our code, which is the optimized solution. Now the last part is define the time and the space complexity. So make sure you write down the time and space complexity during the interview. So um, the time complexity in this case, as we discussed, is log n, where where n is equals to the length of a given array, um, because we use the binary search approach, and in this case the space complexity um, is big of 1 because we didn't use any auxiliary space, extra space to store any intermittent reserves, so it would be a constant space in this case. So yeah, that's it. I hope you like this approach and the solution. Definitely, please comment your feedback, and then please do like, share, and subscribe my channel. Um, and I will see you in the next video. Thank you.